Now before we continue, let's review the concept of the summation symbol, which is this symbol here, because you're going to be using it extensively. The summation symbol, which is followed by some expression here that includes the lowercase I, which is below the summation symbol, means the following. The sum of the expression that is in front of the summation symbol as I changes from alpha to beta. It is easier to see that with examples. For instance, the summation symbol here, I is changing from 1 to 3, and the expression is just xi. What does that mean? You're gonna repeat the expression here as many times as necessary. You repeat everything except for the lowercase I in this case, which is under the summation symbol. The lowercase I is not gonna be repeated. It's gonna change from 1 to 3. So you repeat the x with the I changing from 1 to 3. So basically you repeat everything here except for whatever is here under the symbol. Now that can get tricky. So look at this case here. You're gonna repeat everything here except for what is here, but now everything is in here. So basically the whole xi is changing from 1 to 3. So it's just 1, 2, 3. See the difference between here and here? This is what's going to be changing. Whatever is under the symbol is what's going to be changing. Here only the I is changing. Here the whole xi is changing. It can be any symbol. It doesn't have to be the lowercase I. For instance, consider this case where we have the lowercase j. J is changing from 1 to 10. And the expression is just j itself. So I'm going to keep changing the j from 1 to 10. Notice that the symbol here can be in different places in the expression. For instance, I equals 0 to 3, I xi. So in this case, I am going to again repeat this expression except for the lowercase I. So x, 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 x. But the lowercase I is changing from 0 to 1 to 2 to 3. It can be any function, like here is j squared. So repeat the expression again, j is varying from 1 to 3. Also, not only it can be any function, it can be any limit. It can vary from 0 to 3, from 1 to 10, from 5 to 15, whatever is necessary. And often it's going to vary from minus infinite to plus infinite, for instance, when you are trying to be very generic. So the way to represent this is so on plus, we start with some negative numbers, x0, x1, x2, so on. That's the summation from minus infinity to plus infinity. That's how you denote it. Now, summations have some useful properties. For instance, the summation of sums is just the sum of summations. In this example, I am summing xi plus yi, where I is changing from 1 to infinity. So again, I repeat the expression here as many times as necessary, and so on, because it goes to infinite. And the I is changing from 1 to 2 to 3, etc. But because of the laws of addition, it doesn't matter the order that I add, so I'm going to group all the x's together, and I'm going to group all the y's together. Well, this can be represented by this summation here, because of the definition of summations, and this second part can be represented by that. So this sum is just this sum. Also, we can factor out constants out of summations. Again, that's because of an algebra rule. the summation of AXI, I varying from 1 to 3, is this by definition. We can factor out the A, but if you look just of what I have here in parentheses, that is the definition of this sum here. So I can factor out a constant or factor in a constant, depending on what I'm trying to accomplish.